welcome to the Desk Late Ada.
Hey everybody, and welcome to another late night here at Shea Ada. It's me, Lady Ada. I'm the engineer for the next 10-20 minutes. And with me is Mr. Lady Ada, who's on camera control, VR control, sound control, goth patrol. And we're just chilling here. And by chilling, I mean we're going to do some thermal tests on this Raspberry Pi 3 and test out some heatsink samples. I got some samples of heatsinks, and I did a video before about doing power and temperature tests. And since then, I did a little bit of research and I figured out how you can read the core temperature from the CPU on chip sensor. So I can actually tell not just like the ambient temperature, but the temperature inside the die, which is good. And I also read a little bit about overclocking. I'm not going to do that, but I did determine that, if you run the Pi at max speed, it will eventually slow itself down so it doesn't get above 80 degrees C. So we have the thermal camera. I wanted to kind of go through that again and then also test out. I have a couple different samples, and we'll see which ones work well. And most of us are just going to be hanging out and running this test. So let's go to the compy real fast. Actually, let's go to the overhead, and I'll show off the Pi. This is the Victim Pi 3. So I also have a thermocouple attached to this multimeter. And so just like hanging out, thermocouples are a little slow. Temperature is 32, 35 degrees C. Not too warm, but that's because it's just idle. And so let's go to the compy. Okay, so with your computer, you can, I'm just SSH'd in because again, the serial console actually it will change frequency. And so we ran before this program called Stress, which stresses the CPU. But I also got this handy, there's actually two pretty handy commands. One, this command, which will, it's the Sisyphus, like, file system interface. And you can cat the CPU frequency, and it'll tell you the 4 CPU frequencies. So they're all running at 600 megahertz. And I noticed that when it's idle, it runs at like 600 megahertz. So all the CPUs are like idle, not a lot's going on. And then you can also measure the temperature of the die, and it says it's 44 degrees C. So it is about 10 degrees hotter in the die than it is on the outside of the die. That's pretty normal. There is some, the ceramic package is a little insulative, so it's not going to be able to measure. Measuring the outside will give you a rough idea what is on the inside. But what you really care about is the inner temperature, the die temperature. The package temperature is not relevant. What you really care about is what's going on inside. So you can measure the temperature, and this is like good to about like 1 degree C. It's not like a precision temperature sensor, but it's good enough to give you a rough idea of what's going on. And know that it is warmer than room temperature. So it does run a little bit warm, just even doing nothing. And then we can stress it with dash CPU 4, and this will run on all 4 CPUs. And the moment I run this, if you check the frequency, it bumped up. So it's now running at 1.2 gigahertz, not 600 megahertz. And now what I can do is I'm going to run this. So this is just going to print out the temperature, and you see it's increasing. So then if we go to the Hovercam, and I'll measure the temperature here. Oh, I'm sorry, it's getting in the way. So it's saying 70 degrees C. So it goes up pretty fast. This is again about 10 degrees off. So 71 degrees C, 72 degrees C, and then this is 62. So yeah, it's actually a pretty good thing if you don't want to measure the die temperature. You can measure the outer temperature and just basically add 10. And then do you want to use the thermal cam?
Yeah.
Let's pull this thermal cam.
Yeah, if you if you back out with the Hovercam,
Yeah, I'm backing.
I would go up even more.
Maybe even more.
Yeah.
Okay.
That way, on here you can hold it so folks can see it, but you just gotta get your hands on it.
Yeah, I'm gonna do this. So it says, wow, it's actually pretty hot. It's 197. So I think what happened is, last time I did this, I didn't have a really good power supply, and so it was actually throttling itself because the power supply wasn't very powerful. It wasn't high enough voltage. Now I'm using one of our really good 2 amp power supplies, so it's totally able to supply the current, and I'm reaching 200 degree F, so I can't do math off the top of my head, but that is getting, it's extremely hot. It's close to boiling. So yeah, this is going to be close to. I want to put it in C mode.
Yeah, you may want to try some other modes.
Here, this is. No, that's.
Well, no.
It's in settings, hamburger. Wow, that's really hot.
Yeah. So we can try to change the color a little bit.
Threshold.
Yeah, there's other modes. I actually forget how this works now.
Okay. Wow, 200 degrees F, and it's saying it's 80 degrees.
Yeah.
On.
There we go.
Okay.
So I think we want to do.
That's cool.
Yeah.
So it's reading 210. It's kind of hard to. Well.
Yeah, you can play around with the different.
Yeah, it's actually saying 212 degrees Fahrenheit, which is actually interesting because it's definitely not. I mean, the dye temperature says 80. So I think that this camera, I mean, it's good, but it seems to be a little higher. And then I want to use the now that I've reached that 80 degrees, I'm going to check it with the thermocouple. You have to back it up, yeah. There you go. And then go towards you more. Yeah, it's because the camera's in the corner. So, yeah, that's interesting that it said 200. I mean, I'm not sure exactly why the camera. I mean, I don't know exactly how the thermal camera works that it would say it was 200, but this is saying about 70 degrees ish, depending on how I hold it. It's like 65, 66, 67. So about like 70 degrees C on the outer side of the package. Can you go back to the compy? And then on the inner, and the dye temperature is 80.6. So what's interesting is it actually never gets above 81. And so I was like, well, what's up with that? And then what it turns out is that if you run, a different command, it's not this command, it is it this command? No, it is, hold on, I was writing this up, so I'm going to, there you go, this command will actually give you the specs. And it seems like what's happening is the frequency of the ARM processor actually gets reduced. This is usually like 1.2 gigahertz, so it actually goes down to 1.1. So, I mean, I don't know the details, but I would not be surprised if when you got to 80 degrees C, it started throttling back and saying, hey, you can't, you're not allowed to if you're that hot, you're not allowed to use the CPU. We're going to clock you down. So let me look up 80 degrees C in Fahrenheit, 176. So what's interesting, it said 212, but it's, it's definitely not, because there's no sizzle. I mean, this is like the Robert Pease test, by the way. You lick your finger and you touch the CPU to see if it sizzles. It's not boiling, but it is hot. So yeah, you might want to just be aware, if you're using a thermal camera, especially one that's just like the thermal camera on an iPhone, it's not going to be as precise as either a thermocouple or temperature sensor that's somewhat calibrated, or actually having the internal temperature, which I trust it. I think that this is probably pretty close.
Okay, well, here's a question. Do you recommend a heatsink?
That's a good question. You know, I don't know. I mean, I'm not going to say you need a heatsink, but I do see if somebody's going to be doing a lot of processing, and it's in a very tight container, and they want to get all that processing speed, because it seems to me like, based on that CPU frequency, that is no longer, like the scaling frequency says 1.2 gigahertz, but when you actually ask it what's the clock rate, this is going down. So this was before this was one, just believe me that before it would have said 1.2 gigahertz, and then it's 1.1, and then it's getting a little bit lower, even 1.07. And then now it's 1.05. And I believe that this is the frequency, so I believe that this is going down. So you're going to be losing performance capability if you are cranking it at like ultra speed. So upshot is I wanted to test these heat sinks. So now that I've got it under a stress test, let's check out these heat sinks. So can you go to the Hovercams? Okay, so I've got actually a bunch of different samples here. I got 4 samples. So sample number 1 is this 13 by 13 by 3 millimeter heat sink. So it's not a big heat sink. What's nice about these little heat sinks is they come with tape on them. It's a little bit of a risk because I don't know if I tape this on will I be able to get it off. But you know, this could actually go on the RAM also. The RAM's a little bit warm, but not nearly as warm as the CPU. But you know, you would basically put it on top, and it's nice and skinny. There's also, I got Adafruit Black heatsink, just coincidence. But this kind of heatsink it's a grid of 4x4 little wavy legs. I don't know that much about heatsink design, but this one's goth. And then that one is, sorry, the details of that is 14 by 14 by 8. And then I got a 13 by 13 by 7, so this one's a little bit smaller. It's a little bit smaller, just slightly, and a little bit shorter, slightly, in silver. And then just for kicks, I got this like crazy ass heatsink. So this one's just ginormous. This is a 15 by 15 by 15. So, you know, they're all about the right size for this, but I don't know, which one do you want to try first, Phil?
Black one.
Black one? Okay, well, I'm not able to take this off. So, right now, the temperature, I'm going to turn on watch, it says 81.7, and it never seems to get above that, so I think that's the temperature at which the throttling kicks back. So, basically remove this little thing, and then it's basically thermal sticky tape.
Do you want to answer questions while I do this?
Yeah, sure.
Okay, so the next question is there a safe thermal paste for raw chips?
You know, any paste will work fine. I mean, like, I'm assuming you mean it's raw, as in like it doesn't have the it's not dye exposed, it's ceramic, in which case you can use anything. If it's, I mean, these just have a little bit of thermal tape on them. It's called like 3M 8810, which we actually sell in the store. And it's just a thin little tape, and you cut it and you put it down. And what's nice is that if you don't have a clamp, this keeps the heat sink in, because you know, I'm not going to get like a CPU clamp to clamp this on. Yeah. This is getting a little warm. So let's go to the Compy. So I'm reading 70 degrees. So this dropped the temperature by basically 10 degrees C, which is pretty good. And it's still like 72, just climbing up a little bit. And then I want to see whether, the only thing I couldn't quite figure out is the frequency went back up. So if you'll notice, before it was 10.06, and it was before it was 10.05, and now it's crawling back up. Again, I think that's what I'm looking at here, is the frequency in hertz. So the arm frequency is going up a bit again. But yeah, again, I'm not 100% sure. Okay, temperature. So basically, just to make sure we stay below 80. Looks like this is actually heating up quite a bit. 76, 77. All right, well, I can answer more questions while I'm waiting for this to kick in.
Okay. Someone wanted to know the software we use. We use Wirecast for all this stuff to piece it together live. Next up, question: how did these temperatures compare to the other pies? That's a good question.
The other pies really don't get very hot. Definitely not nearly as hot as this. So I don't have a temperature measurement, but I can tell you just from playing around with the Pi Zero and stuff, they never got nearly as hot. I mean, the Pi 2 would get a little toasty, but I think the Pi 3, it's the 1.2. It's the 1.2 gigahertz, and the fact that it's an ARM8 processor, it really is going a lot harder. All right, so this is getting up to 77 degrees C, 77.4, 77.9. So it is actually still slowly but surely getting back up to 80. So impressive. Yeah. All right, let's keep waiting for this, see how this goes. And then I guess I can try the mega heat sink. So, I mean, I'm going to guess that the little heat sink is like not nearly good enough. Like, you really need to have at least something this big.
Okay,
and
one
maybe
comment
even this big.
and then a question.
Yeah.
Someone that said they can run their Pi Zero stuffed in a wallet for hours and it never gets more than warmish. And then someone wants to know how many layers are in the board. Could they use a copper pour to help dissipate the heat?
It's basically the amount of heat we're talking about. No copper pores won't help. You can only try to remember that there's once your copper pour is more than 1 inch square, it actually the thermal it's not able to. You can only So your copper pour is only going to be useful if it's on the top or bottom layer, right? Because if it's on the inner layer, it's insulated by the fiberglass, which is a great insulator because we use fiberglass to insulate our homes. So you have to have the copper pour on the top or the bottom, and it has to be mechanically connected, like solder connected to the die itself, which I don't believe is exposed underneath this chip. I don't know because I don't have this chip, but it might be, but I don't think so. I think the only way to heat sink it is just clamping something on the top. So given that, this isn't a chip that you could heat sink, there are some chips that you can heat sink, basically if you have a chip, I don't have any here, but there's some chips that have the die, there's a metal chunk on the bottom of the chip that's touched to the die, the silicon is bonded on top of it, and then you can heat sink. They're called HT, TSOPs, and sometimes QFNs, and they have a metal piece in the middle too, that's where the die sits on, so you can use that for heat sinking. But this chip, it's a BGA, so most likely the entire thing is full of solder balls, and so it's floating above the PCB anyway, so you have to kind of heat sink from above.
Okay, do you want to answer more questions?
Yeah, sure.
Okay, next up, will it get hotter in a box?
It will get, the less, if it's completely enclosed and there's not air circulation, it's going to get warmer.
Okay, next up, can't tell if you're doing this way, but to see the CPU speed without running the command, enter this watch VC. You want to look at this command?
No, I mean I have that command, but
Okay.
I'm using it. I'm using the watch command to measure the temperature instead.
Okay, so you don't want me to IM that too?
No, it's cool.
Okay.
I know I have a command. I'm just.
Is anything else at risk, like RAM, like you mentioned? What about power regulation? Will that heat up?
No, the power regulator is not really that warm. I mean, you can look with the thermal camera. It's all on the chip. I can touch the rest of it, and it's totally not a big deal. But even with the heat sink, this is getting really toasty. So this is actually hitting about 80 degrees. So the upshot is this will help you quite a bit, but if you're running for many minutes at top speed, you will eventually, one second, you will eventually still need maybe a bigger heat sink. Hold on, so my core frequency went down. So, so basically this does help, but even with this, it'll still get to a high temperature. So I mean, yeah, a fan, of course, is ideal, but...
yeah, okay. So here's some more questions.
Yeah, what's up?
If the Pi Foundation lets you, would the temperature increase with an overclock? I think a heatsink might be mandatory with 1.5 gigahertz or higher clock, just guessing.
Again, it depends on what you're doing because even like idle right now, I'm not running stress. The clock goes down to 600 megahertz. So if you're not doing anything, it's not going to get hot. It's only if you're like doing stuff. Like I don't even know what you'd be doing on a Pi that would max out it continuously for many, many minutes. But like doing a lot of simulations, like OpenGL plus. I mean, HDMI output is handled by like a hardware core that's separate, so I don't believe that would really speed up the CPU.
Okay, next up.
Yeah.
Do you think a mini fan on a Pi case would be worth doing?
Yes, but again, only if you're going to be continuously running it at top speed for hours.
Yeah.
Like if you're not, I actually think a heatsink's fine. So I just cranked off the little mini heatsink. And now I'm going to try this mega heatsink. I mean, this one's ridiculous, but whatever. I just got ridiculous. This one's gigantic.
Yeah, if you want that command, it'll show both the processor and the temperature.
Oh.
Let me show it to you.
Yeah, you can IM it to me. Yeah. I was like, oh yeah, I know you can do it. I just kind of didn't feel like it.
Yeah.
Okay, so there you go. Here's the heatsink. All right, so now we're talking mega heatsink, and this one, I think it'll fit in a case. It might not. I mean, like, it might actually be a little bit too tall for most cases, depending on what's going on. Okay. Oh, yeah, it's both. I don't know if, hold on. Oh, yeah. That's how, I didn't know Watch could do 2 commands at once. Okay.
Are you got a computer now?
Yeah. Yeah, so this is the command, so we can just watch this, but it's not doing... Oh, sorry. Okay, so now we're going to, with this new heatsink...
Thanks,
okay,
Kirby.
So natively, it's not really doing much. It seems to be oscillating between 600 megahertz and 1.2 gigahertz. The temperature is 47 degrees C. Let's run stress again. And this time with this bigger heatsink, so crawls up to 55. I mean, I should see if I can get, I kind of rushed to get these samples because I was like, whoa, this is right when the Pi came out. Some people were like, oh, you might need a heatsink. So we got some samples. So I only have like teeny and medium and huge. Huge. Let's see how this huge one goes. Yeah, it's getting a little toasty, but it's a nice heatsink. And the real thing I should do is, of course, get the thermal coefficient of all these, because heatsinks do have like a number that's associated with them, which I never remember the units of. It's like degrees per ohm square inch. I don't remember what it is, but you can use that based on the package, which tells you its power dissipation. You can calculate how many watts you can dissipate through that package with the heatsink. Day Counter has a great tutorial on it if you ever checked out daycounter.com. I always just Google for it, and you put in the numbers and they do the little math for you. But I don't have that because like I'm getting these are just like generic heat sinks off of like they're not super happy official. They come from like a factory, and the factory's like, I'll give you a data sheet, but it's like, we're not like engineers, and we just extruded some aluminum and cut it into pieces. So they're not. They're heat sinks, but like I'm not going to be able to get.
Okay, I had this.
Oh, that's handy.
Yeah. So if you keep everything.
Look
there.
at it. We're doing science.
Yeah. Okay.
Okay, so we're going. It's 69. Yeah, this is the one show where I get to kick back and not do much because I'm just waiting for it to. So yeah, this little heat sink, I don't even think this would
next
do
up.
much of anything.
Will there be a power boost upgrade to handle the Pi 3 power needs?
Not planned. I think you've asked that 4 times. Nothing's changed in the last 3 times you asked.
How about now?
Nope.
Are we there yet?
Nope.
Oh, that's something we'll be there.
Mom. Design circuits for me. All right, 73. So even with this one, you know, we're getting pretty toasty. But
I gotta say,
it is keeping the frequency.
To be fair to the question,
yeah.
if you're gonna make it, this has come in from multiple people.
Oh yeah, okay.
Yeah. No, it has.
All right. No, I believe it. It's just like 4 people. I've got 4 emails today saying like, what is up with it?
Look, you know, you're the first stop shop.
I know.
For Power Boost.
The pie's only been out for like 1 week, people.
But Lady Ada.
It was like, does the Pi 2 work? And I'm like, I've only had one for 2 days.
Yeah.
I think somebody already emailed me before the Pi 3 even like arrived at Adafruit. They're like, why does all this stuff work?
Is there any value in putting a heatsink on the voltage regulator?
No, it's not really a regulator. It's a boost converter, so it runs cooler. You wouldn't run a LDO at 2.5 amps anyways, but it runs pretty
Will there ever be a problem with the screen where the display will fail?
Yes. Maybe.
I think they mean for like overheating and stuff like that.
No, I don't think so. I mean, again, it all it does is throttle back the frequency, you know, rather than, it won't destroy itself. You don't have to worry about the Pi like catching on fire.
Yeah.
Like we've solved that. Like we don't have processors melting. Like they have built in thermal regulation basically to chill when they get too hot.
Okay. Do you want to do another heatsink? What are we waiting for?
I'm just waiting to see whether this hits 80.
Well, I see the frequency changes.
Yeah, but it's not changing down. So it looks like if you want to maintain like max speed, you do need to have a ginormous heatsink like this if you're going to be running it for multiple minutes.
Mm-hmm.
Ooh, transparencies.
Just a little bit.
Okay. So yeah, it looks like it's starting to slow down a little bit.
Another question: what's the max temperature of the BCM 2837? It's still getting hot. And then at 1.2 gigahertz on stress, is it even pulling more than the largest Power Boost can handle?
Yeah, probably. I mean, I don't have a power meter, but I would. Yeah, a lot. It's if it wants like an amp or 2. I mean, like again, you know, you can experiment. Then it's people are like, oh, I want like a Power Boost with 2.4 amps, but like, what battery is going to be happy supplying the 4 amps of current required? I mean, like you need a gigantic battery that's just like totally cool with doing that. So, that's a separate problem.
Okay.
Because your efficiency is going to start, plummeting if your battery doesn't like to supply that much current. All right, looks like this will also hit 80 degrees C. So it's interesting is that even with a very large heat sink, you do really need to have active cooling if you want to maintain these high frequencies at such at such long periods of time. All right, so learn something. You don't need a heat sink, but if you want to run it at max capability at that high speed, you probably do.
Okay. Do you want to talk about any of your future plans with the Pi 3? Anything you're looking forward to making, building, doing? I have one.
Well, apparently it's this Power Boost that everybody wants. What?
No. I was going to say Power Boost. No, just kidding. I'm not going to say that.
No, what?
I really liked the video that Tony DeCola did about all the emulation stuff. I think that is cool.
That's cool.
And I just think that that's something to look forward to, like lots and lots of emulation on the Pi 3.
I think definitely there's people going to be doing it.
Because now emulators can kind of go on the go.
Okay, so I removed this heatsink. So yeah, it immediately spiked up to 82. And then you see how that frequency plummeted? So yeah, I definitely think that there is like, that frequency is going to be dynamically changing. It's never going to really get above, you never have to worry about it getting above like 85 degrees C, because it looks like when it hits about 80, it just automatically, the frequency goes down. So it's already down to 1 gigahertz.
Is it possible, you think, to change that in the kernel? Is it hardware? Where is it getting determined?
The frequency of the clock?
Yeah.
That's a good question. I don't know if it's in. I mean, there's going to be some. I believe there is some hardware support for temperature regulation. I mean, it could be a separate. Yeah, I think it's probably done completely inside the CPU. I mean, this is advanced of CPU. It's probably done completely inside. Like, why would you trust your operating system to do this?
You think that there's some type of temperature sensor inside the silicon?
That is the temperature sensor we're reading.
That is throttling the frequency.
I think so.
That's cool.
Yeah.
How would we know? Would we need to get an X-ray of the chip, or like how?
We would look at the data sheet that is not released.
But what if we don't trust the data sheet? Is there any physical way to find out?
The only other way to find out is you would connect to the processor over JTAG, and you would write raw commands to it without an operating system.
See what happens.
To like put it in a loop and basically make the processor run, and then you would see. I mean, or you could just dig through the kernel code and see if there's anything in there. But if you really wanted to prove it, you would connect directly and give it the raw assembly commands.
Okay. Well, I'll call Bunny later and ask what he's doing next week.
Yeah.
Okay. Do you think the PS3 can, the Pi 3 could handle a Bluetooth signal with burning out? Do you think the Pi 3 can handle a Bluetooth signal?
The Bluetooth is a completely separate chip, anyways. It doesn't. This is only if you're like, cracking hashes or like mining bitcoins or like doing a render farm, like you're like, I want to be the next Pixar. Like that's what you would think. What I'm doing to the CPU is abnormal, and you're not going to experience it on a day-to-day basis. Even if you like booted it up and like ran Minecraft and browsed the web at the same time, you're not going to max out the CPU.
Okay. Do you want to? Are you done?
That's pretty much it. Yeah, okay. I think that was some good experimentation. It's interesting. It takes a while for the CPU to come back up to 1.2 gigahertz. It quickly drops, but it takes a while for it to get back up, which is why I think it might be hardware related.
Okay.
Because it's just so fast. Why would it wait for the operating system to tell it?
Yeah. I mean, I guess we could wait till a Pi crashes.
I'm gonna actually try this last little mini CPU.
You want to go back to the?
No, I'm just personally interested in this little CPU.
Okay.
It's a little heatsink for the CPU.
All right. Well, I'll
that's
do some business here. So thanks everyone for watching Jessica Lady Ada. Yesterday we had Ask an Engineer and Show and Tell. Today we had 3D Hangouts with Noah and Pedro, and now we have Jessica Lady Ada. We are viewer supported. That means y'all out there. You run the shows. If you buy kits and electronics and stuff from Adafruit.
Want to touch something hot?
We can keep doing this.
This is really hot. Ow.
I don't feel pain like others. I could see how that could hurt other people.
Yeah.
Yeah, like this burns.
Ow.
Yeah.
Yeah, it's hot.
Okay.
Thanks.
So
Word.
Just make sure that you pick up the kit or tell your friends, or hit like, hit subscribe. If you're on Twitter, follow. These are all little things that we keep track of to make sure that we know that folks enjoy the.
This heatsink ain't doing squat.
It's not doing anything.
This is like the not effective heatsink. I'm glad I got it as a sample, and maybe I'll carry it just because there might be some situations where you really need a teeny heatsink, but I think this one is the minimum. I think you need this goth one.
Yeah. All right. Well, we'll have these and more in the Adafruit store.
Yes, and you see the process by which I test things.
Yeah. And anyways,
yay!
Thanks so much. We'll be around probably this weekend. We have some cool stuff. I'll
probably not streaming tomorrow.
Yeah, I'll give folks a little preview. Let me see how I'm going to do that.
Okay.
Well, I'll try. So I'm just going to turn the camera this way, and over here you'll see a green screen. And over there, you'll see a puppet. We are getting ready to do some more interesting programming, unlike anything that we've ever seen out there. And in our massive apartment here that you can see, which I can. If you go to HugVR/Desk of Lady Ada, you can just see how big the Desk of Lady is. It's very small here, but we'll have that going on pretty soon. So that's a preview, some green screen stuff. So that's Desk of Lady Ada for the week. this week.
Yeah,
And
exciting.
we'll see everybody probably over the weekend.
Oh, and the Tuesday's stream with the Twitch on air sign is a tutorial now. So if you watch that, you can build your own. I put the code up and some photos of me building the sign. It works, so people can build their own Twitch on air sign.
Yeah. Okay. All right, everybody.
Thanks, everybody.
I'll see you soon.
Yay.